Okay, let's start. So today we will discuss about ribbed and waffle slab structures. My name is Volkan, and I've been working as a civil engineer in Proto Group since 2012. You can find my also LinkedIn QR code at the right side. Okay, so I will just briefly show our product, and we will just talk about the some couple slides about the waffle slabs, and then I will show on ProtoStructure how we can model, analyze, and obtain the details from ProtoStructure suite. Okay, so today's agenda is first we will just briefly I will just briefly talk about our products, then I will show the webinar content, and we will continue with the live webinar, and at the end for the last 5 minutes I will take the questions. Okay, ProtoStructure suite is an all-in-one software that can model, design, analyze. You can obtain fabrication details, and of course if you are designing an RC building, you can obtain the RC details as well, and you can also share your models with the other BIM platforms. ProtoStructure suite consists of 4 different products. First product is ProtoStructure, which can model multi-material buildings. You can run finite element analysis and design the members in ProtoStructure side. You can also send this physical model to ProtoDetails, and we can extract all these details from the physical objects automatically. So with just couple clicks, you can obtain all drawings from the ProtoDetails. So our third software is ProtoSteel, that you can create steel connections and you can obtain the fabrication details from ProtoSteel. And lastly, the last product is ProtoBIM, that you can collaborate with the other softwares by using the other BIM formats such as RVT, I mean Revit's file format, or for example IFC, 3ddXF. So these kind of other file formats are supported in the BIM side. Okay, let's talk about ribbed and waffle slabs. So ribbed and waffle slabs are generally used for commercial buildings such as malls, offices, parking structures, and industrial facilities like factories and warehouses, which requires large spans. So the advantage of the ribbed and waffle slabs, they are suitable for longer spans. They are relatively light if you compare with the other slab types, and also you can reduce the foundation costs due to this advantage. Fairly slim floor depths, and so if you use, for example, maybe flat slab or other slab types, you can obtain slimmer floor depths. Of course, it's valid for the same slab span. We can also say robustness as an advantage of the waffle slab, and also excellent vibration control. So there are also some code requirements. So regarding to the Eurocode, minimum flange topping thickness can be 50 millimeters or 1/10 of the clear distance of the rib beams. Depth of the rib beam will not exceed 4 times its width. Rib spacing will be less than 1.5 meters. Also, transfer ribs will be less than 10 times of the depth of the slab. So these code clauses are given in the Eurocode 2 5.3.1. Okay, we will also take these code requirements in our model. So let's see in action. I'm going to create a model. Like we will create a similar model like this. So let's just click to the new button. Okay. I'm going to create a waffle slab. The project code can be waffle slab. And I'm going to select the Polish template in here. This is one of the Eurocode derivative of our templates. So, okay, there are several ways to start a project in ProtoStructure. You can, for example, you can use external reference drawing and you can import all members from DXF drawings, or you can create your model with the grids one by one. For example, you can just create grid system. You can do multiple offsets like this. Okay, you can snap to the grids as well. So you can create grids like this, or you can simply use the third method, orthogonal axis generator method, and we can snap to the grid intersection. So I'm going to use this option. So axis spacing will be 3 times 5 meters, and there will be a small cantilever. And then I'm going to insert the axis spacings on the for y direction axis. So 5 meter, and then 2 times 4 meter will be like this, the grid system. So now we can place our columns. So I will just change the column dimensions from here. I will position them at the center. And we can simply create box around like this. Sorry, again, I'm gonna go. Of course, if you want, you can simply click on the axis intersection like this, or as you see, you can box around on the grid intersections. So if you would like to add a shear wall, you can use the wall command over here, and you can simply insert the wall thickness, eccentricity. If you want, you can also, we have quick eccentricity buttons over here. So I'm going to align on the left side of the axis. By the way, we can also insert the extension lengths. So these extension lengths are inserted as rigid links. So do not insert a more value than the thickness. Okay, so otherwise wall model might be not so correct. Okay, I'm going to insert the shear wall over here and delete this column, and we can insert a column here as well. Okay, so we can continue with the beams. In the modeling tab, we have beam command over here. So what I'm gonna do, I will just change my beam width. You can see beam height over here. If you want, you can also change the eccentricity. By the way, if you want, you can keep the beam level at the same position, but you can slightly shift on the Z direction with the EZ parameter. So let's just box around and we can create all beams at once like this. Okay, I'm gonna also create some cantilever members. If you want, you can box around, or you can simply draw from node to node like this. In the modeling tab, you will see ribbed slabs. So let's just talk about ribbed slabs more. But before, we need to create the load combinations. Now, in this template, I didn't select the Eurocode 8, therefore seismic loading options are not active. So only gravitational load combinations will be generated. But of course, if you want, you can simply activate them from the settings. I will show how you can. But for our topic, it's not necessary. Of course, it's up to the region. For example, in Poland, generally we don't use Eurocode 8, but in some territories such as Greece, Italy, like Cyprus, you need to use the Eurocode 8 due to the seismic hazard. Okay, so first I'm going to start with the rib type. In here, you can select, for example, standard, prefabricated, and grillage option. Standard is actually like standard rib slab. Prefabricated, we are just adding hints for the both end of the rib slab for rib beams actually, and grillage is generally we call waffle slab. You can also call like grillage slab in here, and of course it will be the ribbed beams will be placed on X and Y direction if you select this option. But we will start with first standard. So most of the codes, the minimum width is 100 millimeter. I'm going to continue with the 32 millimeter with the default settings. S block means the rib spacing, but if you uncheck this option, means that there will be holes and there won't be any infill material between the rib beams. So it will just change the self weight. You can see. Let me show. By the way, we can enter values, or you can select the impose those with right click. Because we didn't generate the rib slab, so it doesn't show. Now it will show, yeah, here. So as you see, self weight is 3 kilonewton written in here, but if you just check this option, you will see that it will be increased because infill materials will be considered as well. By the way, I just selected a load from our library, but if you want, you can also manually insert a load from here like this. Okay. Let's talk about the placement of these ribs. For example, rib angle. You can change the rib angle from here, and you can place your ribs on the Y direction. If you want to change the rib position, you can use these corners. Okay, for example, if you select this option, it means that first rib will start 40 centimeters away from the right corner's surface. Okay, let's just check, for example. Let me place again. Yeah, here, as you see, first rib will start from the surface of the beam like this. So if you want, you can, of course, change the other insertion method. For example, you can select left corner or left top corner. Okay, so you can change the positions like this. Okay, let's just use the top right corner. And also, if you continue with the same, so it will be aligned automatically. If you don't want to contribute this slab in the diaphragm, you can select this option. So the slab won't be considered in the diaphragm. Also, if you want, you can insert transverse rib on the other direction. For example, you can see that the software has automatically created a transverse rib on the X direction like that. So let's just insert the rest of them, and you can see that they're automatically aligning at the same position. Okay, you can easily insert these slabs. By the way, we have different slab insertion methods. For example, you can use pick points. So maybe beam region won't be sufficient. So you can simply pick the corners, and your rib slab will be generated just like this. Also, you can use other methods such as, for example, pick axis. So you can simply pick axis in an order, okay, consecutively actually. So then the rib will be generated just like this. And lastly, you can, here we have a single axis region, so you can use the, for example, axis region option for this part. Okay, so if you would like to apply, maybe you have wall loading, so you can go to the load editor and you can apply all wall loads on the beams from here. So you just need to select the wall load. You can select like some wall loads from our library. I'm gonna use the 200 millimeter brick wall. If you want, you can add openings, but in my case, I will not. You can just box around like this, and all ribs, all beam wall loads will be inserted in our loading system like this. So of course, it's also creating loads on the shear walls, so we can easily select them and delete the loads from here if you want. Okay, so I'm gonna create new stories, and I will copy this story information to the other stories as well. So first, I'm gonna use the insert story option, and we can, let's say we will have 3 stories, but I'm gonna use the story 2 for now. If you select generate members from the selected story, it means that it will automatically copy the story information to the second story. Okay, so so you don't have to copy. You don't have to copy the story information via generate story command. Okay, so in this part, I'm gonna delete the cantilevers, and I will create a larger spans like this. Okay, and this time we will use waffle slabs. So what I can do in here, I will transform this rib slab to the waffle slab by selecting the grillage option. Of course, I'm gonna slightly change the actually waffle slab properties. Beam width can be under 50 millimeters, height can be 50 centimeter. I'm gonna place them with the 1 meter spacing. Okay, and a H slab can be 100 millimeter as well. So we can update. If you want, you can also change the positions from here as you wish, or if you want, you can just pick a surface and update. For example, maybe we can select any corner or like this, so it can change the it can change the position like this, okay? Or we can pick the surface. Okay. So what I'm gonna do right now, I'm gonna use the left corner, and we can also again use the beam region with the same orientation. Okay. So we inserted our waffle slabs from here. And lastly, we will have a small roof part. And I'm gonna insert a new story. Again, I will generate the members from the selected story. We can delete some members. So this part, I'm gonna show how you can transform these ribs to the real beam elements. So we can use convert ribs to beam elements. If you want, you can transfer the rib loads directly to the frames, but also you can insert the slabs manually as well. So I don't want to split the beams, that's why I selected the no option. Okay. So in here, again, I'm going to place normal slabs between them. So if you need really, for example, there might be a heavy industrial machine, and you may need to insert a specific load to the point, you can use this feature. Then, of course, we can add some dead and impose loads like this. Okay, so if you use insert slabs automatically, some slabs will be inserted automatically like this. The rest can be easily done manually. Okay, so let me show in 3D physical model. Some of wall loads can be deleted in 3D view as well. Also, you can go to the loading. Here we have load editor, so you can delete them in the load editor as well. But I'm going to use this option, so we can also do these adjustments in 3D view by delete loads command. So as seen in here, we just created our models, which includes ribbed and waffle slabs. So what I'm going to do, I will just run the analysis. So in here, if you go to settings center, you can select the earthquake code if you need. For example, you can simply select the Eurocode 8 from here. Also, you can change the materials. For example, let's use a higher concrete grade, and you can apply all other members with just single click. On the other side, on the right side, you will see the rebar grade. So you can select any rebar grade here, or you can add your custom rebar grade like this, and you can change the rebar properties from here. Okay. We just created loading combinations. and we can talk about a bit model options in here. So shear walls will be finite element shell model. You can change the shell width and height from here. Slab model, we have three different options. You can create rigid diaphragms. If you select this option, then you can mesh the stories, and you can use a flexible diaphragm. Of course, for rib slabs, we will use the rigid diaphragm, but just I'm gonna mesh third story like this. So you can also do this. For example, you can use the rigid diaphragm for all stories, and you can mesh the slabs for the selected story. It's also possible. So the load distribution will be done by finite element method. Okay, let's go to the analysis tab. If you just run the building model check, you can obtain the errors if you did in the modeling part. For example, let me show you. So as seen in here, we didn't do any errors while we are modeling the structure. Okay. So I'm gonna run the building analysis. If I select these options, first two options, it's just checking the design. If you select these options as well, then all reinforcement will be reselected from the settings. So in our case, default settings are existing, so the selection will be done regarding to the default settings. But of course, it will slightly extend the analysis duration. So in our new version, we are considering these ribbed beams as a frame member in the analytical model. You will see soon. Yeah. Once you click to display analytical model, you will see these frames that are considered in the analytical model as well. Okay. So this is also important feature because some softwares that they are just distributing the loads regarding to the slabs in just one way, but we are also taking these, we are just transforming them to frame members, and also taking them into the account of analytical model. Okay, so let's see some diagrams. For example, you can review axial loads. You can just select the load combination and review the diagrams. Yeah, here. And also, for example, bending moments or shear forces can be easily reviewed from the diagrams part. You can also see the, let's just turn off the diagram, and you can also see the animation of the selected, under selected load combination. If there are a seismic effect, you will see the modes on the right side, and you can see the behavior if you select the mode on the right side. So for this model, we haven't used a seismic code, therefore you don't see. But if you will select, you will see the modes, and you can review the behavior of the structure. Okay, so let's just turn off the analysis model. So I'm going to start from the first story. To be able to obtain the ripped beam details, we need to create slab strips. So simply we can go to the modeling tab. I'm going to select the slab strip. In here, first we need to select the direction. So we need to use the same direction with the ripped slabs. Okay, so for this, I'm going to use just on the Y direction. As seen in here, the software is giving a warning that you can that you are using the finite element strip, but there's no results. But in a building analysis, in the finite element strip, if you select building analysis, let me show again. Here, there are some analysis source options. So if you select building analysis option, the software will automatically collect the results from the analytical model, because we are creating these frames in the building model. So this is the most realistic option that you can use for the ribbed or waffle slab design. So of course it will be for span strip, building analysis, boundary conditions. At the beginning we have a beam, so I'm going to select the second option, but at the end there's a cantilever, so you can use the cantilever boundary condition at the end. Okay, so we can insert the rest of the slab strips, and just 3 slab strips will be sufficient. We don't have to insert on the X direction because for ribbed slabs we are just inserting the slab strips on the same direction with the ribbed beams. Okay, so of course now there's also a topping concrete on these ribbed beams. So we can, for this topping concrete, we can insert manual strips and use the minimum reinforcement on X and Y direction, for example. Let's just, so for X direction, I'm gonna use the bottom steel P8 200mm spacing, okay, like this. And also we can also insert on the Y direction. So I will just use top steel. Okay, P8 200mm spacing. So of course we can change the definition span of this reinforcement in the proto details. For now, only 2 slab strip will be sufficient for us. So we can go to the let me turn off this Outlook. Okay, so we can go to the second story, and I'm gonna insert again slab strips for X and Y direction. Again, I'm gonna select the X direction, finite element strip, building analysis, and we can insert. This time I'm gonna insert both X and Y directions, because we have rib beams placed on the both direction. That's why we need to do this. Okay. And also on the Y direction. So these slab strips are at some point giving advantage to me, because I can place anywhere that I want in the plan view. And also, for example, this is orthogonal structure, but there might be some like weird shaped structures, and the also rib beam lengths may change, maybe various. So we can insert any place, and of course beam detail will be prepared according to this slab strips position. Okay, so okay, for both direction we have just placed our slab strips. So after this, of course, for this story we can also insert manual strips, but I will not, because I showed this at the first story. So for topping concrete, you can also insert manual strips in this story as well. So what we can do in here, we can take the results from the analysis results from the analysis model with the ribbed slab analysis button. So in here, the software will collect the results from the all rib lines or from the closest rib to the strip. Okay, generally we don't know the most critical rib, so that's why I'm generally selecting the first option. I'm collecting the results from the all ribs and use the most critical one. So after you run the rib slab analysis, you will see the report of it. So in this report, we are providing some information, that span lengths, beam width, beam height, span and support moments, shear forces. So you can see that these reports are provided in here. And after this, all these internal forces will be transferred to the design part. So I'm gonna go to the rib beams, and of course first we can use the rib settings. For example, let's start with the parameters. So we have the important thing is we have different settings for the each beam group. For example, floor, rib, and foundation beams. So this is important because if you just arrange these settings in the floor beams, it will not affect to the rib ones. So we need to arrange these settings separately. So I'm gonna start with the phi 8. The maximum can be phi 16. Minimum hanger bars you can change from here. If you want, you can also change the link diameter. Maximum support and span spacings can be set from here. Of course, you can change the settings as you wish. You can insert the concrete cover for these beams. Also, for example, if you will use, in our case, there won't be probably a web diameter, but of course, you can also arrange the web steel diameter from here. Rebar patterns. Generally, we use rebar standard pattern 8, but also you can use the bent up pattern 2 with no bent up option. By the way, sorry for the notifications. Okay, so rebar patterns. So you can select the standard pattern 8, and you can set this as a default. But again, please make sure that you select the rib beams, or this adjustment will be just done for floor beams. So don't forget to select the rib beams if you do this, if you apply this setting to the ribbed beams. Okay, set pattern as default. So then we can also change some, if you are using the band up pattern, so you can select the no band up option or other band up options from here. Links, you can we have different link option, different link patterns. If you want, you can also use special torsion links from here. On the other hand, you can change the rip type, closed, open, or standard one. Okay. You can use the same if you want, especially for rip beams. You can use the same link for support and span. You can just specify the position of the lap, lap bar positions in here. So we have different options. You can lap bars inside support. You can extend to adjacent span, or we can do this lapping on the middle of this span here, which is okay. So let's continue with some detail options. For example, you can change the some options. For example, if you want, you can only, for rip beams, you can only create sections on the spans. Steel bars and links, you can generally I select rip load bars below the beam option. You can draw a link label inside like this, but generally I prefer to select display additional link lines. You can see the difference. Also, we have some dimensioning options. You can also dimension first and last links from here if you want. And some detailing options. You can increase the spacing between the details in here if you want. Okay. So let's just reselect all bars. So as you see, all our beams are designed successfully. If you double click on this, one of the part of, actually this one is waffle slab on the second story. So as you see, the software has provided the rebars. If you want, of course, you can play with these rebars. For example, you can just reduce and add support top bar from here if you want. Okay, like this. So different adjustments can be done manually. We have also detailed report. So we are providing all clauses that we use regarding to the Eurocode or ACI in here. So you can see the like banding calculations, shear design, and at the end you will see the deflection checks regarding to the Eurocode. Here you can see. Okay, so as you see, the deflection is satisfying the limits. So let's continue to the Prota detail side. Of course, for all beams, you can also obtain detailed reports or summary report. But I suggest you to create summary report if you have a lot of beams, rib and waffle beams, because it may take thousands of pages in the detailed report. So let's just close this interface and we can save our model. Then I'm going to pass to the Prota detail side to obtain the details of this waffle and rib slabs. By the way, I think there are some questions. I will take them at the end, so don't worry about it. Therefore, I recommend you to stay in the webinar till the end. So I will take the questions. So Prota Details can generate all drawings at once. In here, we have auto-generate details option. Okay, so I haven't selected the reinforcement of columns, so I just turned them off. But just I left form plan and rib beam details. You can change the options if you want. You can add form plan side dimensions automatically. We can, but I will show manual how you can add automatically manual as well. So that's why I'm turning off this option. You can print, for example, steel bar total length or show number of bars in the bar label. These kind of options can be activated from here. And you can also change the hatch patterns from this part. So we can use the solid ones, for instance. I don't want to draw story 0 because we haven't generated any foundation, so therefore I will just turn it off. Okay, so for example, for form plans, I will not create a sheet, but for rib beam details, we can insert them to the sheet. So you can see that we have multiple options. For example, you can place them in a sheet, but for form plans, you can place your sheet manually if you want. Okay. So I'm just clicking on a point on the screen, and the details will be generated automatically. So normally creating such details manually will take maybe days, but with just a couple clicks, we created all details precisely like this. By the way, all CAD commands are available in here. For example, if you want, you can slightly move all these members to the downward like this. Of course, like hatch, copy, stretch, extend, all these commands are available, and you can use this software as a CAD software. So let's just add some, for example, for side dimensions like this. We have automatic dimensions option. You just need to pick 2 points, place the dimensions, and they will be automatically dimension all members. I'm gonna do the same in here. Okay. So in some softwares you need to pick each point, but we are automatically detecting these points and dimensioning them. Of course, we are also creating these dimensions automatically when you generate the form plans, but I just wanted to show you that we have also different options. You can also add a form section, for example, even so we know that there's a rib slab, so we can activate the ortho mode with F8, okay, and we can simply place this. Just I'm gonna change this position in here. Okay, so we can simply place this section like this. So what I'm gonna do, I will just add a sheet for the form plans. So I have implemented my custom sheet, which is a bit larger than the existing ones. So you can see that my custom sheet has been placed. You can also add your logos, and you can change this sheet details with just couple click. For example, in the project header, you can change these values. Okay, like this. So all these informations will be automatically applied to the sheet. You can also review the details. We just prepare this written waffle slab beam details precisely. All these reinforcements are intelligent, so you can customize them. For example, if you just click on this one of these rebar, you can see that segment lengths are placed in here, so you can insert any value for this segment lengths. Okay. And also you can see that these reinforcement has been placed like this regarding to the manual strip. So okay. If you would like to save this drawing, you can press the Control S button on your keyboard, or you can simply use the Save Drawing command. And lastly, we will export this drawing to the to your CAD software with the Export DWG option. Okay, so the relevant drawing has been exported like this. Okay, so let's finalize our presentation. So we have Proto Help Center. If you have any questions, if you need tutorial videos, reference manuals, so you can reach to the Proto Help Center, and you can review our detailed documentation and videos. In our website, we have white papers placed under resources, so you can review our white papers. You can also subscribe our YouTube channel, and we are also adding new videos, webinar recordings, some tutorials in our YouTube channel. So I recommend you to subscribe our channel to follow our latest videos. You can connect with our social media accounts, LinkedIn, YouTube, Facebook, Instagram. And if you would like to purchase the software, you can contact with the global sales at protosoftware.com. So thank you for your attendance. I'm gonna take the questions now. Okay. So is there any beam at E-axis? Let me check. I don't remember. No, there is no, but if you want, you can add. It's up to you. In some cases, they are adding because they don't want to see these rib actually thicknesses, so they add a small beam on this cantilever edge. But it's up to you. It's up to the designer. So in this case, I haven't added, but we could. So both modeling methods are correct, and it's up to the designer. So I'm going to take the second question. Sorry. Okay. So the buttons are a bit small, so it's hard to see. Okay. Could I create concrete zone area around the waffle slab like 50 centimeter? Yes, you can. For example, I think you want to do something like this. Okay, if you'd like to create this inside of the beam region, you can do like this. You can transform them to the real beam elements. You can delete part of these beams and insert a single slab to these regions. But if you are talking about as a cantilever, you can also insert like type 12. And also you can specify the cantilever length. Okay. So both options can be done. So I couldn't guess the exact situation, but I think I answered for a couple possibilities. My question about first story. Let me check. And yeah, okay, yeah, we already explained this. Sir, why it's let me my question is about the first story. So why it's not showing the reinforcement detailing in the section? Okay, for standard slabs, we are able to provide this, but for ribbed slabs, unfortunately, it's not able to provide these details, but we are working on it. But if, for example, like if we could have a slab strip in here, because we have real slabs, then we could see the rebars on the section. Yeah, but for slab, for ribbed and waffle slabs, the section doesn't show the rebar details. Okay. So in our case, I designed as rectangular, but you can also use the T section, because we have analysis option in such case. Is this structure is orthogonal? Yes, it is. So is it possible to simply support each rib slab panel? Yes, it's possible. For this purpose, you need to select the a second option, prefabricated one. So if you select this option, we are adding hinges for the both end of the rib beams. Is it possible to model tapered beams? Unfortunately, no. Tapered beams are not supported yet, but it's in our development list, and we are aiming to develop this feature in upcoming versions. Section doesn't fit the reinforcement. What do you think the best solution to fast change? So if the section doesn't fit the reinforcement, so you can increase the diameter and reduce the bar number, or you can simply increase the section. Otherwise, concrete will not place well, so it might be a problem for us. Section. Okay, I meant between beam and waffle slab. So if you want to do this, Mr. Abu Jabal, if you want to do this, you can do that. You can use the same method as I did at the third story. So you can convert them to the real beam elements, delete the part of the beams, and place a single slab. So it's possible to model this in the protostructure. And I don't think that most of the softwares may not model this kind of scenario. Okay, does the analysis recognize the waffle beam nearly? Yes, yes. Let's check. Let's check. So you mean this small one? Because yeah, if the axis would be on the left side, it might be a problem, but there's a gap, so you can. Let's just open the analysis. Let's just open the building analysis. We don't have valid analysis, but probably it will show the previous result. Okay, so in here, you can see that this beam, which is created closely to the main beam, has been generated. Okay, but of course, actually, I didn't see this, but the most appropriate method, because it's not a good modeling approach, so we could slightly switch to the left side. Okay, like Mr. Abu Jabal, yes, it's possible. You can also add hidden beams as well, and you can place the you can create such a zone with the converting members to the real beam elements and place the slab members on around of this region. Mr. Vaipa, sorry for surname. Mr. Vaipur, Vayapur. So I couldn't see your first question. Let me check. How explain? How the structure is orthogonal? I mean orthogonal because there is no. I meant because it's orthogonal because there is no angle. I mean, all members are placed on X or Y direction. That's why I said orthogonal. Maybe you understood a different term. Okay, so let's continue. Can you use solid slab over column with the same thickness? Solid slab over with the same thickness. Yes, I mean we can use drop panels, or we can create a different. We can add axis around of the column, and we can insert a different slab to this region. It's possible. Can we have a session in the future on waffle slabs without internal beams? To say where the slab rests directly on columns. Yeah, generally, so you can do this with the normal beam elements, Mr. Opare. So because otherwise it's not possible to create a single waffle slab like this. So I mean, you can simply transform all these. Let me show the third story. You can simply transform the waffle slabs like this to the real beam elements. You can add slabs like this if you want, and this kind of approach can be done. Otherwise, there will be a load loss warning. Mr. Ogba, how can we place a wall line load on the waffle beam only? So, like, if you transform this, if you transform to the, if you convert it to the real beams, it's easy. You can simply edit loads, but for the other parts, for this, we are not showing. Here, yeah, we are not showing. We are not able to insert them separately, like frame loads. So if you want, you can, if you have such a specific load, you can simply transform to the real beam elements like this, and you can insert a frame load. Okay, we have slab strip inserted. So if you have slab strip inserted, the software will not allow you to delete the any member. So make sure that you deleted slab strip first to be able to delete some components. Okay, so you can simply select the frame member and insert a uniform load like this. Okay, I will take just a couple questions and finalize the webinar. I would like to inquire whether it's possible to model precast beam to the block slabs in similar manner to these ribs. Additionally, I seek guidance to how assess deflections and ensure that the limiting span lengths for these pre-stressed precast beams are not exceeded. So, so what you can do is, I mean, as I know, in precast systems, they're just hinging the both ends, so you can use this option, prefabricated one, or you can simply transform to real beams, and you can add these hinges manually, okay, from here. So then you can review the detailed report that we are providing the deflection deflection results. Okay, last question. For deflection, what the protocol doesn't. Okay. Please may you discuss the design of the transverse rib beams. So, Mr. Ver, transverse rib beams are actually used for as a detail, because so you can use the, we are just collecting all results, so transverse ribs are considered in here. But of course, if you want, you can review them in the analytical model. If it's exceeding, you can just transform to the real beam elements and take the detail from there. You can just save as another model, transform. Generally, transverse ribs, we use the same detail as we provided in here. But if you want to obtain a detail again, you can convert RIBs and just take the relevant transverse RIBs detail to place your sheet. To place your ribbed slab sheet. So this is only way to obtain the transverse ribs details because we are not providing it. Okay, so I took the last question. Thank you for your attendance. And I will be waiting all of you in my next webinar. See you.